In recent months, one of the most unusual and intriguing waves of rumors in years has begun to form around Tesla. While the entire world is focused on the development of artificial intelligence, Optimus humanoid robots, cybercab autonomous taxis, and massive computing centers for AI training, some analysts are increasingly paying attention to another direction that until recently seemed like pure science fiction. This refers to the potential development of Tesla's first flying vehicle. It all began after Elon Musk, in one of his conversations with Joe Rogan, once again touched on the topic of flying transport. Formally, no official announcement about the launch of such a project has been made. However, Tesla investors have long been familiar with Musk's pattern. Very often he first casually mentions a technology, and then a few years later it turns out that internal work on that exact direction has already been underway for a long time. This was the case with Optimus robots. This was the case with autonomous driving. This was the case with cybercab. That is why even a small hint from Musk generated enormous interest among analysts, engineers, and journalists. In recent weeks, several industry observers have noticed an interesting pattern. Tesla is actively developing three directions simultaneously. The first is autonomous driving. The second is artificial intelligence. The third is new transportation platforms, including the robovan. And the more experts analyze these projects, the more often a theory emerges that in the future, they may all merge into a single device. Some analysts even suggest that the robovan itself could become the foundation for Tesla's first flying vehicle. To begin with, it is worth recalling what the robovan actually is. When Tesla first presented this concept, many viewers were surprised by its size and unusual design. Unlike the company's familiar vehicles, the robovan looks more like something from a science fiction future. It is a large autonomous electric vehicle designed to transport a large number of passengers or cargo. Tesla has stated that such a machine could be used as next-generation public transport, a corporate shuttle, a tourist transport system, a logistics platform, or even a mobile office. The main idea is that the absence of a driver allows for a complete rethinking of interior space. But it is precisely the size of the robovan that has unexpectedly become the main argument for supporters of the flying version theory. The fact is that creating a fully functional flying car comes with a huge number of engineering constraints. Small flying machines face serious limitations in energy capacity, stability, and safety. A larger body, however, allows for the integration of far more batteries, computing systems, redundant control systems, and propulsion units. Some specialists believe that if Tesla truly intends to develop a flying vehicle, the most logical starting point would be the robovan platform. Interestingly, a similar strategy is now being used by many companies working in the field of aerial mobility. Instead of building flying sports cars, they are focusing on large autonomous vehicles designed to transport people along predefined routes. Such projects are being developed by American, European, and Chinese companies. Some of them are already testing vertical takeoff and landing vehicles. However, none has yet achieved large-scale commercial success. This is where Tesla could gain a significant advantage. The company already has extensive experience in battery development. Tesla operates its own battery manufacturing plants, its own energy management systems, and has vast experience optimizing vehicle weight. In addition, Tesla possesses one of the most powerful artificial intelligence infrastructures among automotive companies in the world. Regarding autonomous driving, the amount of data collected by Tesla vehicles around the world already amounts to billions of kilometers of real-world driving experience. Some experts suggest that autonomy itself could become the key to the emergence of Tesla's flying transport. Looking closely at the development of the industry, it becomes clear that the main obstacle is not so much flight itself, but control safety. Humans are capable of making mistakes. In the air, the cost of an error is significantly higher than on the road. That is why many specialists believe that the first mass-market flying vehicles will be fully autonomous from the very beginning. Imagine a scenario 10 years from now. You request a vehicle through a Tesla app in the same way people order a taxi today. Within minutes, a next-generation autonomous robovan arrives at a dedicated platform. After passengers board, The system automatically checks weather conditions, air traffic, battery status, and the route. Then the vehicle smoothly lifts into the air and travels to its destination without a pilot. All control is handled by Tesla's next-generation artificial intelligence. Today, such a scenario sounds like science fiction. But just 10 years ago, the idea of a car capable of driving itself through a city without a driver sounded equally unrealistic. Today, millions of people are witnessing the development of this technology in real time. However, between a concept and a real product, there is still a huge gap. That is why analysts identify a whole list of challenges Tesla would need to solve. The first challenge is energy. Even the most advanced batteries have a significantly lower energy density compared to aviation fuel. Flight requires an enormous amount of energy, especially when it comes to vertical takeoff. This is why many engineers consider batteries to be the main limitation of the entire industry. The second challenge is safety. If a conventional car can pull over to the side of the road in case of a malfunction, airborne transport does not have that option. This means highly redundant systems will be required. Each critical component may need multiple independent backups, from motors to computing modules. The third challenge is regulation, which many experts consider the most difficult factor. Even if Tesla were to demonstrate a fully working prototype tomorrow, it would not immediately reach the market. Regulators in the United States, Europe, and Asia would require years of testing and safety validation. A new category of transport would require new certification standards, new operational rules, and entirely new infrastructure. And this is where things become especially interesting. Some analysts believe that artificial intelligence itself could accelerate this process. The more reliable autonomous systems become, the easier it will be to convince regulators of their safety. Given the pace of AI development in recent years, this situation may evolve much faster than many expect. The question of cost is equally important. If Tesla were to actually build a flying robovan, how much would it cost? Expert estimates vary widely. Some suggest prices above $1 million per unit in the early stages. Others believe that thanks to mass production, Tesla could eventually reduce the cost to a few $100,000. But almost all analysts agree on one point. Early versions would not be aimed at private consumers, but at commercial transport services. This is where a potential revolution begins. Imagine a future megacity. Millions of people spend hours every day stuck in traffic. Roads are congested. Building new highways becomes increasingly expensive and difficult. In such a situation, the use of airspace looks like an extremely attractive solution. Instead of constructing thousands of kilometers of roads, cities could gain an entirely new transportation layer above existing infrastructure. Some futurists call such a system a three-dimensional transport network. Unlike traditional roads where vehicles move in two dimensions, aerial transport gains the ability to use the third dimension. This fundamentally changes the principles of logistics and human mobility. If Tesla turns out to be the first company capable of implementing such a concept at a mass scale, the consequences for the industry would be enormous. Competitors would face an extremely difficult choice. Either urgently invest billions of dollars into developing similar solutions, or risk losing a significant share of the future market. Companies from China are paying particularly close attention to the situation. Chinese manufacturers are already heavily investing in air mobility technologies. Several Chinese companies are testing electric vertical takeoff and landing aircraft. Some analysts believe that China and Tesla could become the main participants in a new technological race over the coming decades. But looking even further ahead, the consequences could extend far beyond the transport sector. The emergence of mass aerial transport could transform city architecture, real estate markets, tourism, logistics, construction, and even the structure of employment. Districts that today are considered remote from city centers could suddenly become only a few minutes of flight away from business districts. Some investment banks are already modeling such scenarios. According to several forecasts, in the event of the emergence of affordable autonomous aerial transport, the value of certain categories of real estate could change in highly unexpected ways, as people would be able to live significantly farther from their workplaces while maintaining minimal commute times. This is precisely why so much discussion is currently emerging around Tesla's potential flying project. there is still no official confirmation of such a product. There is no presentation, no prototype, no concrete specifications. But Tesla's history shows that many of the company's boldest ideas were initially perceived as science fiction and then gradually turned into real products. This is why every new hint from Elon Musk triggers such a strong reaction from analysts around the world. And if one day a flying robovan truly appears on stage alongside Cybercab and Optimus, that moment could become one of the most important events in the history of modern transportation, because it would no longer be just about a new vehicle, but about the beginning of an era in which humanity gains the ability to move through the air as easily as it currently orders a taxi via a smartphone. As analysts delve deeper into the topic of a potential flying robovan, more and more questions arise about how exactly Tesla could implement such a project in practice. Many experts point to one interesting pattern. Almost all major Elon Musk projects initially seemed impossible. When SpaceX spoke about reusable rockets, most specialists considered it too difficult and economically unfeasible. When Tesla announced its intention to make electric vehicles mainstream, the automotive industry met the idea with skepticism. When the company began talking about Optimus robots, many analysts called it a distraction from its core business. Yet today, reusable rockets have become the standard for SpaceX. Tesla sells millions of electric vehicles, and Optimus is gradually moving beyond the laboratory stage. This is why some investors are closely watching for any indirect signs that a new direction may be forming inside Tesla. In recent years, the company has significantly strengthened its capabilities in artificial intelligence, autonomous control, and energy systems. For a conventional car, this already provides a major advantage. But if the focus shifts to flying transport, the importance of these technologies increases dramatically. In recent months, one of the most unusual technological intrigues of recent years has begun to form around Tesla. It all started after Elon Musk once again hinted in an interview that the company is working on a next-generation transportation system capable of changing humanity's perception of urban mobility as radically as the Model S once transformed the electric vehicle market and Starlink revolutionized satellite internet. At the time, many people dismissed these remarks as just another bold statement from the billionaire, something he has become famous for over the years. However, the situation now looks very different. More and more information is beginning to leak from within the company, and some analysts and industry insiders are convinced that Tesla is genuinely preparing to unveil the first prototype of the most ambitious transportation project in the company's history. This is not simply about a new car. It is not even just about a new robo-taxi. According to numerous rumors, Tesla is actively developing a flying version of the Cybercab, which has allegedly been given the internal name SkyCab. If this information turns out to be even partially accurate, humanity may be on the verge of seeing the first mass-market autonomous flying taxi created by a company that has already demonstrated its ability to turn science fiction into a commercial product. Interestingly, the first discussions about such a project appeared several years ago. At that time, Elon Musk cautiously acknowledged that the concept of a flying car seemed interesting to him, but existing battery technology did not allow for a sufficiently safe and efficient solution. The primary challenge remained battery energy density. A vehicle that must not only drive, but also take flight, requires an entirely different level of battery efficiency. Every additional kilogram of battery weight requires greater lift, which in turn increases energy consumption. But over the past few years, the situation has begun to change rapidly. Tesla has been investing heavily in new generations of batteries. Production of 4680 cells continues to scale up. At the same time, the company is working on dry electrode technology, improving energy density, and reducing the weight of battery packs. Some analysts believe that these advances may have provided the technological foundation Tesla needed to launch the SkyCab project. Additional interest comes from the fact that Tesla has increasingly been mentioned alongside the eVTOL industry in recent months, electric vertical takeoff and landing aircraft. Many experts consider such vehicles to be the future of urban mobility. Today, dozens of companies around the world are developing similar projects. However, most of them are creating purely aerial transportation. Tesla, according to the rumors, wants to go much further and combine the capabilities of a car and an aircraft into a single vehicle. Imagine a typical morning in a future megacity. Millions of people are commuting to work, roads are overloaded, traffic jams stretch for dozens of kilometers. But instead of sitting in a sea of cars, a passenger summons a skycab through the Tesla app. Within minutes, a compact autonomous taxi arrives at the house. For several kilometers, it travels on ordinary roads, then leaves a designated traffic corridor, activates its vertical takeoff system, and rises above the city. 10 minutes later, the passenger is already on the opposite side of the metropolitan area. This is precisely the vision of the future that analysts increasingly describe when discussing Tesla's potential project. Particular attention has been drawn to reports from insiders who claim that Tesla is already testing a number of technologies required for such a vehicle. These reports focus primarily on artificial intelligence and autonomous control systems. Many experts believe that this is where the company holds a tremendous advantage over its competitors. While a conventional aircraft requires a trained pilot, the skycab is reportedly intended to be completely autonomous. According to some rumors, the control system will be based on the next generation of full self-driving technology. In essence, the artificial intelligence will simultaneously perform the roles of both a vehicle driver and an aircraft pilot. To achieve this, it will need to process enormous volumes of data in real time. Cameras, next-generation LiDAR systems, radar sensors, satellite navigation, Starlink connectivity, and the computing power of Tesla's future AI chips will all have to function as a single unified organism. Particularly intriguing are the rumors suggesting that the skycab project may utilize Starlink infrastructure. While a conventional vehicle makes decisions locally, a future flying taxi could receive additional information from a global satellite network. This would make it possible to coordinate the movement of thousands of aircraft simultaneously and minimize the risk of collisions. Some insiders claim that Tesla is considering the concept of aerial corridors. Similar to road networks for automobiles, special routes could appear in the sky along which autonomous taxis would travel. Artificial intelligence would continuously calculate optimal flight paths, avoiding bad weather, heavy air traffic, and other obstacles. But perhaps the most fascinating question concerns the possible appearance of the skycab itself. Here, the rumors diverge. Some sources claim that the aircraft will resemble an enlarged version of the cybercab with integrated electric rotors. Others speak of a completely new design inspired by futuristic aviation concepts. Some even speculate about folding wings that would automatically deploy during flight and retract after landing. If Tesla truly unveils such a vehicle, its specifications could become one of the biggest technological sensations of the decade. According to preliminary estimates from analysts, the ground driving range could reach approximately 500 to 700 kilometers, while flight range could extend to 250 to 400 kilometers, depending on payload and weather conditions. At the same time, road performance would remain comparable to modern Tesla electric vehicles, while airspeed could potentially exceed 250 kilometers per hour. This would mean that travel between major cities could be reduced dramatically compared with traditional automobile transportation. That is why many analysts are already describing the skycab project as potentially Tesla's most revolutionary product since the arrival of the Model S. If electric vehicles transformed the automotive industry, autonomous flying taxis could fundamentally redefine the very concept of transportation. And the more rumors emerge around the project, the stronger the impression becomes that Tesla may indeed be preparing to show the world something far more significant than just another new car. If we look closely at Tesla's recent actions, it becomes apparent that the company is gradually assembling nearly every technological component required to create such a transportation system. Many investors traditionally view Tesla as an automaker, but the company itself has long been attempting to move far beyond the automotive industry. Today, Tesla is simultaneously involved in artificial intelligence, robotics, energy systems, battery technology, supercomputers for neural network training, and even indirectly participates in the development of global satellite infrastructure through Elon Musk's close connection with SpaceX. When analysts put all of these pieces together, a picture begins to emerge in which the SkyCab project no longer appears as fantastical as it did a few years ago. Of particular interest is the question of how such a vehicle would be charged. Many skeptics immediately ask, if a modern electric vehicle requires dozens of kilowatt-hours of energy for ground transportation, how much energy would be needed for a machine that must also take flight? According to estimates from some aerospace engineers, takeoff is by far the most energy-intensive phase of flight. However, once altitude is gained, energy consumption can decrease significantly, especially if the design uses aerodynamic surfaces and gliding elements. According to rumors, Tesla may be using a new generation of batteries that has not yet been officially unveiled to the public. Some sources claim that the company is experimenting with higher energy density battery packs that would increase range without significantly increasing the vehicle's weight. If that is true, SkyCab could become the first mass-market aircraft capable of completing dozens of short urban flights without recharging. It is also interesting that Tesla already operates the largest fast-charging network in the world. Some analysts speculate that future supercharger stations could include dedicated aerial terminals. Imagine a massive Tesla facility of the future. On the lower level are conventional charging stations for cars. On the upper platform are landing pads for SkyCab vehicles. After landing, the aircraft automatically connects to a next-generation ultra-fast charging system and is ready to fly again within minutes. Safety is another topic that deserves special attention. Many experts consider safety the biggest obstacle to the widespread adoption of flying vehicles. If an engine failure on the road usually results in a vehicle stopping, the consequences in the air can be far more serious. That is why, according to rumors, Tesla is considering multiple layers of redundancy for all critical systems. According to some reports, SkyCab could feature several independent electric motors. Even if one or more of them fail, the aircraft would still be able to safely complete its flight and land. In addition, some sources claim that Tesla is exploring the possibility of integrating a full vehicle parachute system. In an emergency, a special ballistic parachute could automatically deploy and reduce the vehicle's descent speed. Another fascinating topic is the potential price of such a vehicle. Estimates vary dramatically. The most conservative analysts believe that the first versions of SkyCab could cost more than $200,000. However, Tesla supporters point out that the company has repeatedly demonstrated its ability to dramatically reduce the cost of new technologies once mass production begins. Electric vehicles were once considered toys for millionaires. Then Tesla introduced more affordable models that began competing with traditional automobiles. If history repeats itself, flying taxis could become accessible to a much broader audience just a few years after launch. Some investment banks are already modeling scenarios in which Tesla creates not just a new form of transportation, but an entirely new industry. According to their projections, the urban air mobility market could eventually be worth hundreds of billions of dollars annually. The reason is simple. Most major metropolitan areas are not gaining more land. Cities continue to grow vertically, populations keep increasing, and road infrastructure is becoming increasingly overloaded. At some point, humanity inevitably begins looking for additional space for moving people. That space is the sky. Interestingly, many experts compare the potential arrival of SkyCab to the emergence of smartphones in the late 2000s. Before the first modern smartphones appeared, people viewed phones primarily as devices for making calls. Then an entirely new category of products emerged and transformed the lives of billions of people. A similar transformation could occur in transportation. Today, most people view a car as a vehicle that travels on roads. But if a form of transportation emerges that can move freely between roads and the sky, the very definition of an automobile will begin to change. Recent statements by Elon Musk have once again sparked a wave of discussion around one of Tesla's most ambitious projects in the company's history. During a closed meeting with Tesla investors and engineers, first reported by several American technology bloggers, Musk allegedly joked that in the future, cars should be able not only to avoid traffic jams, but to leave them entirely. At first glance, it sounded like another one of Elon's jokes. However, only a few days later, several insiders connected to Tesla and SpaceX suppliers began claiming that a secret project related to vertical takeoff technology actually exists inside the company. What makes this especially interesting is that it is not said to be an aircraft or a drone, but a fully fledged flying Tesla vehicle. The most intriguing part is that these rumors began emerging almost simultaneously from multiple independent sources, which usually happens only when active development is already underway inside a corporation and information starts gradually leaking out. The situation became even more intense when analysts noticed unusual Tesla activity in patent areas related to ultra-light composite materials, compact thrust distribution systems, and new ultra-high-density batteries. Several documents published in the US patent database describe technologies that appear far too unconventional for a standard electric vehicle. Furthermore, some of these technologies overlap with SpaceX developments in thrust control and thermal management. This has led many experts to speculate that Tesla may be preparing not just another car, but an entirely new transportation category. While the idea of a flying car once seemed like science fiction from early 2000s movies, an increasing number of analysts now argue that Tesla could be the first company capable of turning the concept into a real mass-market product. According to several American publications, including sources close to former Tesla employees, a small, highly confidential engineering group has existed within Tesla for years, operating separately from the main Autopilot and Optimus teams. Its activities are reportedly classified to an extreme degree, and employees sign expanded non-disclosure agreements. Some insiders claim that the project is internally known under the temporary codename Skyline, although Tesla traditionally changes project names before public launches. Another interesting detail is that some engineers assigned to the group previously worked at SpaceX on Falcon 9 stabilization systems and rocket landing software. This appears particularly unusual because specialists with such expertise are rarely transferred into the automotive division without a significant reason. Many observers have also recalled Elon Musk's comments from several years ago when he suggested that Tesla could theoretically create a vehicle equipped with elements of the SpaceX package, a set of miniature compressed air thrusters. At the time, most people dismissed the idea as another example of Musk's futuristic trolling. Today, however, against the backdrop of rapid advances in artificial intelligence, autonomous piloting, and battery technology, those statements no longer seem quite so far-fetched. Moreover, according to several Wall Street technology analysts, Tesla may have achieved substantial progress in next-generation battery development with significantly higher energy density. Batteries have always been the primary obstacle to compact flying transportation because existing technologies remain too heavy for extended flight. But if Tesla has indeed moved closer to producing a new class of ultra-light batteries, the situation could change dramatically within the next few years. Some insiders claim that Tesla is discussing not merely a flying car concept, but the creation of an entirely new category of future personal transportation. In essence, the project is described as a hybrid of an automobile, artificial intelligence, and an autonomous aviation platform. The vehicle would supposedly be able to travel on ordinary roads and, under certain conditions, switch into a vertical takeoff mode. And this is where Tesla's artificial intelligence plays a key role. The company already possesses one of the largest road data networks in the world, thanks to millions of vehicles collecting information from roads every day. If this is combined with autonomous aerial navigation, Tesla could gain an enormous advantage over all competitors. In effect, the company could create the world's first unified AI system for managing both ground and air traffic. This is why many analysts believe the project could be far larger than it appears today. It may not simply be an expensive toy for billionaires, but an attempt to completely transform the infrastructure of future megacities. Already, the world's largest cities are facing transportation gridlock. Traffic congestion continues to worsen, building new roads is becoming nearly impossible, and urban populations keep growing. Flying transportation has the potential to change the very architecture of cities. Imagine a world where thousands of autonomous Tesla vehicles move through aerial corridors above cities, all managed by a single artificial intelligence system. a world where people no longer spend 2 hours sitting in traffic because their vehicle simply rises into the air and follows the optimal route. For many, this sounds like science fiction, but only 10 years ago, Tesla's autonomous cars also seemed impossible. Particularly interesting is the market's reaction to all these rumors. After the first leaks appeared, some investors began actively discussing the possibility that Tesla was preparing a new iPhone moment for the transportation industry. Several major technology channels on YouTube and analysts on X started comparing the potential launch of a flying Tesla to the moment Apple first unveiled the iPhone, because if successful, Tesla could effectively create an entirely new market with trillion-dollar potential. And it is important to understand that Elon Musk has repeatedly entered industries that were considered impossible to revolutionize. SpaceX transformed the space sector. Tesla changed the electric vehicle market. Starlink is reshaping global internet access. Neuralink is attempting to connect the human brain to computers. As a result, many investors have long since stopped viewing such ideas as mere fantasies. At the same time, however, a huge number of problems and questions arise. The biggest issue is regulation. Even if Tesla were to create a working prototype of a flying car, transportation laws around the world would need to be rewritten completely. Airspace is currently tightly regulated by aviation authorities. Every flight requires complex certification and control systems. Imagine what would happen if thousands of autonomous vehicles began flying above cities simultaneously. Who would be responsible for safety? Who would control flight routes? What would happen if the system failed? How would collisions be prevented? How would such vehicles be protected from cyber attacks? All of these questions are already causing serious concern among aviation safety experts. There is also another problem: noise. Even modern small drones generate significant sound, and if millions of flying cars were operating above major metropolitan areas, cities could face an entirely new level of noise pollution. This is why some analysts believe Tesla may be working on a fundamentally new propulsion system that would be much quieter than traditional rotor-based designs. Once again, rumors point to possible use of SpaceX technologies and new magnetic solutions. Some engineers speculate that Tesla is attempting to create a distributed electric propulsion system with dozens of compact, nearly silent modules instead of large rotors. If true, this would represent a technology capable of transforming aviation itself. Another reason the rumors appear so believable is the current state of the market. Chinese companies are already actively testing eVTOL platforms, electric vertical takeoff and landing aircraft. Several startups in the United States and China are already conducting piloted tests of air taxis. However, most of these projects resemble small helicopters or drones rather than full-fledged automobiles. Tesla, on the other hand, could potentially take a completely different approach. The company is known for making products both mass-market and visually appealing. If Tesla were to unveil a futuristic flying car with a Cybertruck-level design and full AI control, the impact could be enormous. Discussion intensified even further after users noticed unusual activity near the Gigafactory in Texas. Several drones filming the factory grounds from a distance captured the movement of unidentified covered structures whose shapes did not resemble either automobiles or standard Tesla production modules. Of course, this is not evidence, but the internet immediately began constructing theories. Some bloggers are convinced that Tesla is already testing early elements of a new platform. Others believe the company is intentionally fueling speculation ahead of a major event. Elon Musk understands perfectly how the information effect surrounding Tesla works and often uses mysterious hints to generate enormous attention long before official announcements. If Tesla does unveil its first working concept within the next few years, the consequences could be immense. The automotive industry would be stunned. Traditional automakers that have only recently begun catching up to Tesla in electric vehicles would suddenly face another technological revolution. Aviation companies could also find themselves under pressure because a portion of short-distance urban flights could shift entirely to a new format of personal aerial transportation. Even the real estate market could change. If people can reach a city center in 10 minutes through the air, the importance of distance between home and work would be completely transformed. Suburban areas could expand even faster. and the structure of major metropolitan regions could undergo dramatic changes. Some experts believe that a fully commercial version of such transportation is unlikely to appear before the mid-2030s. Even if Tesla is already working on a prototype, years of testing, certification, and refinement still lie ahead. However, the company could theoretically present a demonstration concept much sooner, especially considering Musk's fondness for ambitious futuristic presentations. Analysts suggest that Tesla might initially introduce a limited version for private properties, corporate campuses, or specialized routes. Only years later could the technology reach the mass market. As for pricing, forecasts vary widely. Some believe the first flying Tesla car could cost more than $300,000 or even $500,000. But Tesla's history shows that the company consistently seeks to reduce costs over time. Electric vehicles were once considered toys for the ultra-wealthy, yet today, Tesla sells millions of vehicles worldwide. If the company succeeds in creating a functional platform, similar vehicles could become far more affordable within 10 to 15 years, especially if Tesla can automate production and integrate the new system into its existing gigafactories. But the most important point is something else entirely. A flying Tesla car could become more than just a new mode of transportation. It could mark the beginning of an entirely new era. For the first time in human history, artificial intelligence, autonomous control, electric technology, and aviation could be combined into a single system designed for mass use. And if that truly happens, the world 20 years from now could look completely different from today. Cities would change, roads would change, logistics would change. Even our perception of distance between people could disappear. And that is exactly why rumors surrounding Tesla's mysterious project are generating such enormous interest around the world. Throughout its entire history, humanity has been obsessed with the same fundamental, almost sacred dream: to break away from the ground and achieve true freedom in the sky. For centuries we have looked upward, envying birds whose wings seemed like nature's highest gift, and step by step, through blood, mistakes, and titanic effort, tried to replicate that gift. The evolution of our engineering thinking is astonishing. From fragile wooden gliders and early, barely controllable parachute jumps to supersonic passenger airliners and heavy military fighter jets. But if we look at it objectively and honestly, has this progress answered our deepest inner demand? Unfortunately, no. The modern person, when buying a plane ticket, is not truly flying in the sense a bird does. They sit inside a closed metal capsule, look through a tiny window frame, and drink coffee while a computer guides a multi-ton machine through the clouds. This is movement through space. This is a triumph of logistics, but it is not flight. An airplane completely isolates us from the sky. It does not transmit the feeling of wind, nor that primal sensation of your own body mastering air currents. Even extreme activities like parachute jumping or wingsuit flying are only prolonged, albeit controlled, falls limited by the grammar of gravity and by a few minutes before the canopy opens. Humanity has remained a prisoner of the ground, never fully able to experience what it truly means to fly. Of course, the industry did not stand still. In recent years, a number of ambitious technology companies have come into the spotlight, among which the British Gravity Industries led by Richard Browning stands out as a clear leader. They have created something that just yesterday seemed like science fiction. Full jet-powered flying suits turning a human into something like Iron Man from Marvel Comics. Their systems, producing more than 1,000 horsepower through miniature jet engines on the arms and back, are already being actively tested by elite units of the Royal Marines and rescue services in hard-to-reach mountainous terrain. But let us be honest, the current versions of these suits are far from becoming everyday reality for billions of people. They are extremely heavy, require immense physical training and phenomenal balance, run on conventional aviation kerosene, are unbearably loud, and, most importantly, their autonomous flight time is limited to a mere 5 to 10 minutes. This is an amazing attraction and a niche tool for special forces, but not personal transportation of the future. However, we did not decide to make this video in order to once again melancholically reflect on the unattainability of true freedom and technological dead ends. Quite the opposite. Right now, before our eyes, behind the scenes of the global technology market, events are unfolding that prove that in the near future, the possibility of full-fledged, accessible, and safe personal flight for humanity will not only appear, it will become the new normal. And these are not empty words, not futuristic fantasies, and not clickbait. The reason for such tectonic shifts in the media landscape and expert community was the monumental news coming from Wall Street. The world's leading technology giant, the manufacturer of the most advanced reusable rockets, Elon Musk's company SpaceX, has officially gone public in an IPO, carrying out the largest initial public offering in human history. This historic event not only cemented Musk's dominance in the space industry, but also officially made him the first trillionaire in human history, as he controls about half of all company shares. SpaceX raised colossal, unprecedented funding, tens of billions of dollars in live cash, which, according to official statements, will be directed towards scaling the global high-speed internet satellite network Starlink, deploying orbital data centers for artificial intelligence, and accelerating the Starship program for the colonization of Mars. However, the most intriguing, sensational, and truly explosive fact emerged literally days ago. Reputable financial media outlets, including Bloomberg and Financial Times, citing their own high-level sources and insiders within Silicon Valley, shook the information space with news that SpaceX leadership and the top management of Gravity Industries have begun exploring potential strategic cooperation. At this stage, if the reports are to be believed, the discussion is limited strictly to closed preliminary talks and analysis of technological compatibility. Official representatives of both sides are either silent or issuing standard vague statements. But independent analysts unanimously argue that even the existence of such rumors represents a tectonic shift for the entire global transport industry. Because if these giants truly join forces and begin joint work on a next-generation commercial personal flight device, what emerges from the intersection of their capabilities would be nothing short of a nuclear combination. On one side, Gravity Industries, with its unique patents in human flight ergonomics, integration of control systems with natural human biomechanics, and experience working with 3D-printed composite polymers. On the other side, SpaceX, with its limitless financial resources, the world's best rocket engineers, access to cutting-edge alloys, and most importantly, technologies for engine miniaturization and artificial intelligence systems. So what might their potential collaboration and resulting product look like? Experts suggest a shift away from noisy and dangerous kerosene turbines toward a fundamentally new architecture, the so-called Gravity E-suit, a fully electric or hybrid suit. The main problem has always been battery energy density. But SpaceX, closely connected to Tesla's automotive developments and space energy systems, has access to secret solid-state battery technologies and ultralight fuel cells. Insiders hint that the new suit could be based on micro-rotating detonation engines or high-efficiency plasma microaccelerators adapted for operation in dense atmospheric layers. Visually, it would no longer be a bulky backpack with heavy arm-mounted thrusters. The SpaceX Gravity collaboration is aiming to create a lightweight anatomical exosuit made of carbon fiber and flexible graphene plates, worn like a tight athletic bodysuit. Control would be completely transformed. Instead of supporting body weight with arm strength like Richard Browning does, the user would be protected by a powered exoskeleton frame. An integrated SpaceX neural network, trained on millions of hours of flight simulations, would read the user's micro-muscle movements, balance, and head tilt in real time and automatically adjust the thrust vector of hundreds of micro-nozzles distributed across the suit. The person would simply lean forward and fly, spread their arms, and bank into a turn, while the computer fully eliminates the risk of stall or loss of control due to sudden wind gusts. The projected technical specifications of such a device are said to be revolutionary. Estimated speed of a production model would range from 150 to 250 kilometers per hour, while flight altitude for safety reasons would be software limited to 300 to 500 meters, although the technical ceiling would be significantly higher. But most importantly, thanks to new energy sources, flight endurance would increase from 5 minutes to a full 1.5 to 2 hours, transforming the suit from an expensive toy into a genuine means of transportation. When such technologies could potentially become a reality for the commercial market, leading analysts at Morgan Stanley and Goldman Sachs, assessing the pace at which SpaceX is deploying its raised capital, agree that the first working prototype of a joint production project could be presented to the general public within 3 to 4 years. The start of small-scale production and the first closed sales for technology enthusiasts and government agencies are forecast around 2031 to 2032. Of course, the key question for most people will be price. In the early stages, as is always the case with breakthrough technologies, the cost of the suit will be extremely high. According to insider estimates, the first production units could cost around $350,000 to $500,000, comparable to a premium supercar. However, Elon Musk's business model has always been based on gradual cost reduction through mass production. Following the analogy with electric vehicles, 7 to 10 years after the launch of the first model, meaning closer to the end of the 2030s, the market could see a kind of Model 3 equivalent in the world of flying suits, a mass-market civilian version priced at around $40,000 to $50,000, available through credit or long-term leasing to the middle class. Moreover, flight-sharing services and tourism hubs are expected to become extremely popular, where such a suit could be rented for the weekend. The emergence of such a product would not just change the world, it would fundamentally rewrite human civilization, triggering an infrastructural and social revolution. Imagine how our understanding of travel and daily logistics would change. The concept of traffic jams would disappear forever. People would no longer spend hours stuck on bridges and interchanges. A commute from a suburban home that once took 2 hours by car could take 15 minutes in a straight line through the air. The very architecture of cities would change. Urban planning would shift focus from road surfaces to building rooftops, which would become flight terminals, parking replacements, and charging stations. A large-scale decentralization of megacities would begin. Why live in a crowded city center if you could own a house in a scenic forest or by a lake 150 kilometers away and fly there faster than taking the metro? Tourism would become completely different. People would be able to explore canyons, mountains, river valleys, and inaccessible jungles while literally gliding above them at bird's-eye level with no environmental damage. But of course, such a radical technological leap carries enormous, unprecedented risks, and these will become the main stumbling block. The first and most powerful barrier against early enthusiasm will be regulatory risks and the position of governments worldwide. The Federal Aviation Administration and similar agencies in Europe and Asia will be alarmed by the prospect of millions of uncontrolled flyers in urban airspace. A completely new legal framework will need to be built from scratch. Special air corridors will have to be designated. Automatic collision avoidance systems will need to be developed, and pilots will likely require strict licensing. Intelligence agencies and police forces will raise security concerns. How do you control borders if anyone in a suit can fly over a fence? How do you prevent intrusions into private property, protected sites, or government rooftops? Regulators will likely require strict software-based restrictions, so-called no-fly zones embedded into the suit's GPS module, physically blocking propulsion systems when approaching airports, military bases, or nuclear power plants. The second category of threats is purely technical and physical. Unlike a car, where an engine failure simply leaves you stopped on the roadside, in a flying suit, any major system failure or battery depletion at 200 meters altitude would result in a guaranteed fatal outcome. Engineers will have to implement full redundancy across all critical systems. If 3 micro-rotors fail, the remaining 40 must still be able to keep the suit stable and bring it down safely to the ground. A mandatory safety feature will be an integrated ultra-fast emergency parachute system with a pyrotechnic deployment charge, capable of deploying even at an altitude of just 10 meters above the ground, as well as airbags that instantly inflate around the pilot in case of dangerous proximity to the ground or buildings. In addition, the human factor cannot be ignored. Panic attacks at altitude, reckless flying behavior, collisions with birds, power lines, or delivery drones. In summary, it can be stated with confidence: will such a product be a revolution? Absolutely yes. It would represent the greatest civilizational shift since the invention of the wheel or the internal combustion engine. In recent months, events have begun unfolding in the automotive industry that just a few years ago seemed like pure science fiction. While most people continue to debate whether electric vehicles will be able to completely replace gasoline-powered cars, the world's largest technology and automotive companies are already looking much further ahead. They are not simply considering a new powertrain, but a fundamentally new way of transportation. And if industry sources are to be believed, the era of traditional automobiles may be much shorter than many people think. According to several insiders connected to the American automotive industry, Ford has begun work on an extremely unusual project. It involves a next-generation vehicle concept that is being considered inside the company as one of the most ambitious projects of recent decades. Some sources claim that it could become Ford's first flying pickup truck, designed in the style of the legendary F-Series lineup. There has been no official confirmation so far, but the idea itself looks far more realistic than it did even 5 years ago. The reason is simple. The world has reached a point where the existing transportation system is beginning to face fundamental limitations. Cities are becoming larger, urban populations are growing. The number of vehicles on the roads is increasing faster than infrastructure can develop. Millions of people spend hours in traffic jams every day. In some megacities, the average speed of movement during rush hour is already approaching the speed of a cyclist. And this is happening despite the tens of billions of dollars that governments invest every year into expanding roads and building new interchanges. Engineers have long understood that roads cannot be expanded forever. Sooner or later, humanity will face a limit. That is why more and more companies are beginning to look upward, literally upward. The airspace above cities remains almost empty compared with overcrowded roads. And if it becomes possible to create safe, relatively affordable, and mass-produced flying transportation, it could become the biggest transportation revolution since the invention of the automobile. At first glance, the idea seems crazy, but if you look more closely at what is happening, it becomes clear that the world's largest companies have already been moving in this direction for years. Over the past decade, tens of billions of dollars have been invested into the development of electric vertical takeoff and landing aircraft. Such projects are being developed by companies in the United States, China, Europe, and the Middle East. Some have already conducted real test flights. Others are preparing for the commercial launch of air taxi services. In many ways, we are witnessing the same situation that existed at the beginning of the 20th century with automobiles. Back then, most people considered cars an expensive toy for the wealthy. Horses seemed much more practical. But within just a few decades, everything changed completely. Today, many experts believe history could repeat itself. According to sources, discussions about a potential Ford flying pickup truck did not begin by accident. The company is closely monitoring the development of autonomous driving technologies, high-power electric motors, new types of batteries, and ultra-light composite materials. It is precisely the combination of these technologies that is making such a project technically possible for the first time. If we imagine such a vehicle of the future, it would be very different from modern cars. Most likely, it would be a hybrid between an automobile and an aircraft. Such transportation could move on regular roads, but, when necessary, take off and overcome congested sections of a route through the air. Some concepts suggest using multiple electric rotors distributed across the body. Others involve folding wings or specialized ducted fans. Interestingly, such transportation could solve not only the problem of traffic congestion, it could completely transform logistics. Imagine a farm hundreds of kilometers away from the nearest city. Today, delivering equipment or cargo requires hours of travel on roads. A flying pickup truck could cover such distances along a direct route. This would mean shorter delivery times, lower costs, and fundamentally new opportunities for businesses. But even more interesting are the potential consequences for urban environments. If such transportation becomes widespread, the very architecture of cities will change. Special landing platforms will appear on the rooftops of buildings. New residential complexes will be designed with air transportation in mind. Shopping centers could have their own aerial terminals. parking lots may gradually transform into multi-level vertical takeoff and landing hubs. Of course, the main question arises: when could all of this become reality? Most analysts agree that mass adoption of such vehicles should not be expected within the next few years. Even if Ford is truly working on such a project, it is most likely part of a long-term strategy. However, the first demonstration concepts could appear much earlier. Some specialists believe that the first full-scale prototypes of next-generation consumer flying vehicles could be presented by the end of this decade. Limited commercial sales could begin in the early 2030s. The first models will almost certainly be extremely expensive. Prices could range from $200,000 to $500,000 per unit. However, history shows that as production scales up, the cost of such technologies usually drops dramatically. Electric vehicles are a good example. Just 15 years ago, they were seen as a niche technology. Today, millions are sold worldwide. Flying vehicles could follow a similar path. But along with the opportunities come serious challenges. The most obvious one is safety. If an engine failure on the road often simply results in a vehicle stopping, the consequences in the air could be far more serious. That is why future flying vehicles will require multiple layers of system redundancy. Each engine could potentially be backed up by several independent modules. There will likely be automatic emergency landing systems, intelligent collision avoidance algorithms, and constant data exchange between vehicles. An equally serious challenge will be regulation. Today, airspace is controlled by aviation authorities. But what happens if tens of thousands of flying vehicles are simultaneously operating above a major city? A completely new air traffic management system will be required. Many experts believe that solving such a challenge will be impossible without artificial intelligence. That is why AI development is becoming one of the key factors in the future transportation revolution. Autonomous systems will be able to calculate optimal routes, avoid collisions, and coordinate the movement of millions of vehicles simultaneously. Essentially, this means creating an aerial equivalent of the internet, but instead of transmitting data, it will move people and cargo. Another major issue is infrastructure. Mass adoption of such vehicles will require thousands of new facilities, next-generation charging stations, air terminals, traffic management systems, maintenance centers. All of this represents a massive market worth hundreds of billions of dollars. It is no surprise that interest in this sector comes not only from automotive companies, technology giants, battery manufacturers, aerospace corporations, and even construction companies are gradually entering the field. Everyone understands that what is at stake could be the creation of a new global-scale industry. But the most interesting part is that flying vehicles could change not only transportation, they could change the very geography of how people live. If the journey to work takes not an hour by road, but 10 minutes through the air, many people will want to live much farther away from major cities. This could lead to the development of new districts, the emergence of entire aerial suburbs, and a redistribution of population. Therefore, when rumors appear that Ford is working on a flying pickup truck, it is not just about a new vehicle. It is about a potential symbol of the next transportation era. The same way Henry Ford's first mass-produced automobile once became a symbol of a new age. Of course, today it is still impossible to say how quickly such technologies will become part of everyday life. History knows many projects that looked promising but never became widely adopted. However, one thing is already clear. The discussion about the future of transportation is no longer limited to the debate between gasoline and electricity. The next stage could be far more radical. Perhaps in 20 years, children will look at today's traffic jams the same way we look at photographs of cities filled with horse-drawn carriages, as something belonging to the past, as an era that once seemed permanent but unexpectedly ended under the pressure of new technologies. And if the insider information turns out to be even partially correct, then somewhere right now, Ford engineers may already be working on a machine that one day will rise into the sky and forever change our understanding of what an automobile can be. However, the most interesting part begins when analysts try to imagine not the flying vehicle itself, but the world that will emerge after its mass adoption. And this is where the forecasts become truly impressive. Many experts believe that the transportation revolution caused by the emergence of flying cars could be even more significant than the transition from horses to automobiles a century ago. The reason is that the modern economy is literally built around roads, cities, warehouses, logistics centers, retail networks, residential areas. Everything was designed around the idea that people move across the ground. If a significant part of transportation can move into the air, almost everything will change. According to industry insiders, this is exactly why many automotive companies are already creating specialized research divisions focused not only on developing the aircraft themselves, but also on studying the infrastructure of the future. Some internal reports suggest that the first cities adapted for aerial transportation could appear as early as the 2030s. This would involve dedicated air corridors, intelligent navigation systems, and automated landing platforms located literally every few kilometers. Imagine the morning of an ordinary person in 2040. Instead of leaving home and sitting in traffic for 40 minutes, they go up to the roof of their residential complex. There is a compact landing platform there. Their personal vehicle automatically calculates the route, receives approval from the air traffic management system, and lifts into the air within seconds. While the passenger drinks coffee and reads the news, artificial intelligence completely controls the flight. 10 minutes later, the person is already on the other side of the city. Today, such a scenario sounds like science fiction, but these models are increasingly being discussed at industry conferences. It is also interesting that a potential Ford flying pickup could become especially valuable in rural areas. Unlike urban air taxis, a pickup truck would have completely different purposes: transporting cargo, working on construction sites, delivering equipment to remote areas, assisting emergency services. That is why some sources claim that Ford is considering the concept of a heavy-duty multi-purpose aerial vehicle capable of carrying hundreds of kilograms of payload. If such a project really exists, it could use technologies that are now being developed for next-generation aviation. For example, distributed electric propulsion. Instead of one large engine, the vehicle could have 10, 12, or even 16 smaller motors. This configuration improves safety and allows the aircraft to remain controllable, even if several motors fail at the same time. But another question arises: what will happen to traditional cars? Will they disappear completely? Most experts believe they will not. Just as airplanes did not replace cars, flying transportation will not eliminate ground vehicles. Most likely, they will coexist for many decades. For short trips around the local area, people will continue using regular cars. For long-distance travel and avoiding traffic congestion, aerial vehicles will be used. Eventually, a hybrid transportation ecosystem will emerge, where each type of transport occupies its own role.